One other note I wanted to mention about definite integrals is that so far we have always had our definite integrals be evaluated where a is the lower number and b is the higher number. If you have a definite integral and this is the case, then we're calculating the signed area. That means all of the area above the x-axis is counted as positive, and all of the area below the x-axis is counted as negative. That's traditionally how we do things. So on the vast majority of definite integrals you're going to see in this class and beyond, the a is going to be smaller than the b. However, if a was less than b, but we flip-flopped their order on the integral, what that means is we have to essentially take our definite integral but integrate backwards. Now, this is simply going to be the negative of the signed area. In other words, it's going to treat every triangle above the x-axis as a negative area and every triangle below the x-axis as a positive area. So it's basically, if I change the order so that the smaller numbers on top and the bigger numbers on bottom, then I need to integrate and flip the signed area. I go from a negative to a positive. Anything above the x-axis is treated as negative in that case, and anything below the x-axis is treated as positive. Now, what I do, if ever this is not in order, I just calculate the signed area and then I put a negative out front. Let's do an example of this one. This one says take the definite integral from 4 to 1. Notice that, again, we're starting with the bigger and ending with the smaller, of x minus 3. Let's go ahead and do this. I've drawn the line segment here from 1 to 4. Notice that it crosses the x-axis, so I'm going to have two triangles. Normally, we'd count the signed area to say the triangle below the x-axis, the one I've shaded in red here. I've counted that one as negative, and the triangle above the x-axis I'd count as positive generally. Because I'm integrating the other direction, I'm going to do it the opposite. Now, I'm just going to calculate the two triangles. Notice that the red triangle, the one that's below the x-axis, has height of 2 and base of 2, from 3 to 1, from 0 to negative 2. So the height and base are both 2. The triangle above the x-axis has a base of 1 and height of 1. Let's fill that in. The triangle below the x-axis, we said has base of 2 and height of 2. That means the area of the triangle below the x-axis is 2. The triangle above the x-axis had base of 1 and height of 1. So the triangle above the x-axis had area of 1/2 or 0.5. I think I'm just going to write 0.5. Normally, the signed area, therefore, would be a 0.5, that's the above part, minus 2, which is the below part. That means if we would have integrated from 1 to 4, we would have ended with a negative 1.5 as the signed area. Or integrating from 1 to 4, x minus 3 with respect to x gives me a negative 1.5. If I would have swapped the 1 and the 4, and I've put the 4 on the bottom and the 1 on the top, then all I have to do is negate the signed area. And when I integrate from 4 to 1, I get a positive 1.5. So this is how integrating in the wrong order, generally speaking, when you start with the higher number and you end with the lower, you're doing this in a wrong order. So generally speaking, we don't do this. But if you did happen to put the bigger number on bottom and the smaller number on top, you would have just gotten the negative of your signed area. Hopefully that makes sense. Again, this is something to be careful of when you're writing things down. Therefore, we've completed this, and we understand that if we integrate in, we put the bigger number on bottom, we just get the negative of the signed area. Don't forget, this is what's going to lead us to the next couple of sections. Don't forget that we have been utilizing straight lines here so we can take advantage of the geometric properties of straight lines, things like triangles and rectangles. But if we don't have straight lines, we're going to have to think of something other than just our rectangles and triangles in order to figure out the area between the curve or the function and the x-axis. And that's what's going to motivate the next couple of sections.